What we're going to do in this video is look at a complete example of a mixed factorial design in ANOVA, where you have one between subjects variable and one repeated measures variable or more. And so this data set is the repeated measures 2 ANOVA data set, and I'm on page 152 of the notes. And one thing is this data set's been used a couple times now, so what I'm going to do is get rid of everything from subject through these FSG variables, because those were really for double repeated measures. So now I have this group and this BSG set of variables. So what's going on in this study is we gave people pairs of words to estimate their relatedness. So if I give you cheddar and cheese, you're supposed to tell me how many times out of 100 if I said cheddar, would the next word from someone be cheese? It's very similar to Family Feud. And so people are pretty bad at this task. And we're really interested in why are they bad at this task. So in the last video, the double repeated measures video, I showed you that they were particularly bad at it because of backward strength. So if I give you sirloin to steak, the answer is only about 8 people. If you said, 80 people, if I said sirloin first, would say steak second. In the reverse, though, if I say, okay, well, how many people, if I said steak, would say sirloin? The answer should be about 8, 10, somewhere in there. But because the reverse pair has such a high relationship, it messes you up, and that's backwards strength. And so in this video, I'm going to look at how backward strength being low, so not too much of a relationship on the flip side, or backward strength being high, a large relationship on the flip side, can mess me up. So that's my repeated measures variable. People got both of them. In the group variable, what we did was we had 2 different types of instructions. One of them is called JAM. It's a Judgments of Associative Memory task. And what it is it's just the regular set of instructions. So we explained to them how they're supposed to guess at these words. So if I said cheese, how many people out of 100 would say cheddar? This was developed by my advisor at Texas Tech, Bill Mackey. And so he's published a couple articles on like how people are bad at doing this sort of guessing. And we have a couple more papers about why there's a problem. And the problem is backward strength, we think. Okay. The other thing that we did was we came up with a set of debiasing instructions. And so bias is our sort of the problem where we tend to overrate the low ones and sort of guess just right on the high ones. And so we're biasing our scores upwards. And so the idea with the debiasing instructions was people are bad at this task. Here's how they're bad at this task. You should not be bad at this task. It's a little more complicated than that, but the idea is that we told them how and why people are bad in the hopes of fixing that problem. So this is a 2x2 mixed factorial design. Okay, so it is a 2x2 ANOVA, where there are 2 levels of the between subjects, 2 levels of the repeated measures, but we're going to call that mixed ANOVA, because that makes it clear that there's one of each, okay, at least one of each. All right. If I wanted to calculate the power for this type of design, I would use G-power. And with G-power, what we're trying to do is figure out how many participants we need. So I'm going to go down to F-test and then pick from the options. Okay, so we're going to pick the repeated measures within between interaction because we're most interested in the interaction, and this is one of the only ones that has a mixed interaction. This one is the one-way interaction, okay, and this one's ANCOVA. We're not there yet. I can estimate an effect size. I wasn't too sure about this one because I didn't know how effective my instructions would be since we sort of made them up. But if I was to tell you that the effect size, since I have run this before, is fairly small, so let's estimate from eta here. So I'm going to hit determine. And then direct, and let's estimate it at 0.01 as a small effect size. So let's say calculate transfer to main. And so that makes it almost perfectly the 0.10 for small a half. For alpha it's 0.05, power is 0.8. Okay. The number of groups is going to be the number of levels between subjects, so that is 2. The number of measurements is the number of repeated measures, also 2. Correlation among repeated measures. We talked about this one before. It's the lowest correlation between the two repeated measures pieces. So I could calculate that real quick. So analyze, correlate, bivariate. I'm going to move over my two repeated levels and hit OK. That's 0.625. Okay, so there's a high correlation between them, rating them low and high, which is not too surprising. So I could enter that here, 0.625. If you don't know, 0.5 is a good guess, somewhere between 0.5 and 0.7. The non-sphericity correction you won't really know beforehand, but that's epsilon. You get that in Mockley's test. So I'm hit enter. It tells me I need 148 people to find the effect size that exists, because this is a small effect size. In the notes I did a medium effect size. Okay, so 148. I think I have 150 something in my sample, 158. So if that effect exists, I should be able to find it with this sample. What you'll see here in a minute is that that effect probably doesn't exist, and there is not going to be an interaction because this data set, not every data set I have is perfect. Now, in the real study, we ran this as a 2x2x2, so we actually combined the double repeated measures video and this one together, but I wanted to show you just doubly repeated and then just interactions. Okay, just one mixed interaction, so we didn't have to do a three-way design. Okay. All right, so that's G-power. I need 148 people. I have 158. Hopefully that'll be enough. Okay. All right, the next thing I'd want to do is check for accuracy and missing data. Now, when you're doing accuracy and missing data, remember that you're going to want to screen your grouping variable just to make sure you haven't entered anything goofy, like a random 3 out there. And then that's the last time you'll use that until you run the analysis. So analyze, descriptives, and then frequencies. Let's move over all 3 variables. Under statistics, we can pick min and max. If we wanted nothing else, we could leave it alone, but often I want to look at the mean and standard deviation, make sure it's not 100 points on a 100-point scale, which would be really weird. You can ask for skew and kurtosis to kind of pre-check for normality, but not a whole, if you have an outlier, you've got to fix that first. Continue, and then we'll leave the charts off. We won't check them until we need to. Okay, turn off the frequency table so you don't get gigantic decimal tables. Hit OK. All right, so accuracy-wise, I should only have 1s and 2s. Here are my group variables, so that looks like it's probably OK. The rating variable for my DV only runs from 0 to 100, so that also looks OK. I don't have any missing data. Great, I've checked my first 2 problems. I could look at the means and standard deviations for these groups. And so that doesn't seem too unusual to me, considering it's a 100-point scale, a 10-point standard deviation is not too high. You don't really want to look at the mean and standard deviation for your categorical variable because that doesn't really stand for anything. All right, let's check for univariate outliers on our 2 repeated measures levels. So analyze, descriptives, and then descriptives. Move over your 2 continuous variables, or your levels, and then save standardized values as variables. That's create me z-scores, please. Hit OK. Now I'm going to go back to the data. I only have 2, so this is pretty easy to check. If you had a lot more, you could analyze a frequency table of the new z-scores, and that would tell you if anything was out of range, which is 3. But since I only have 2 of them, this is kind of easy to sort. Ascending, nobody in this one. Close, but no banana. Descending, nobody on the top. And then do the same for the other variable. Oops. Ascending. Okay, got 2 outliers here on the bottom of people whose scores are the lowest on this BSG high, which is the same people from the last video. And then descending, nobody here at the top. Okay, so I have 2 univariate outliers. Since I have more than one measurement time of my DV, so I have more than one level for my repeated measures, I probably want to check this as multivariate instead, so I can look at the pattern of DV scores and see if there's anybody unusual. So if you looked at the repeated measures video, you'll notice that sometimes the univariate outliers are not multivariate outliers because their pattern isn't weird, but then there are univariate people who don't show up on a z-score whose patterns are strange. So I really like using Multicollinearity because it gives me a better picture of the pattern of data across multiple variables rather than just one little snapshot at a time. So to do that, I have to first create a random variable, transform compute, random here. I'm going to click on R for random numbers, and then RV chi-square. I'm going to pick 7 as my favorite number to start from, and OK. And more info on that is provided in the data screening video that's uploaded on YouTube. Now, to actually get Multicollinearity, I'm going to do a fake regression. So analyze, regression, and linear. I'm going to put my random variable in the dependence box, my 2 continuous variables in the independence box, ignore group. Remember, you only really screen it to make sure you don't have any typos or missing data. You do not screen it as an outlier because you forced them into those groups. Plots, z pred into y, z residual into x, histogram and normal probability plot. Continue. And save Multicollinearity. Continue, and OK. All right, let's look at the data. So I'm going to sort this data descending, and I would have to come up with a cutoff score. I don't think typing cutoff score there was going to help me much. There we go. So I want to use the number of variables I stuck in my independence box, which is 2 degrees of freedom. Remember, don't subtract any numbers. That's for testing, not for data screening. And I'll use 0.001 because I want them to be very, very strange before I start to delete anybody. So I got 1382 here. And I do have one person who's an outlier, and they're also the univariate outlier. So in this particular case, I might delete them. Let me see. I don't think I did for the rest of the notes, so I'm going to leave them in so I can match with what the notes have going on. But you could delete them in this case. It's one particular person whose scores are pretty high, and you have a big sample. I'm going to leave them in to match what I did with the rest of the notes, though. All right. So the next step would be multicollinearity. Okay, multicollinearity is just a bivariate scatter plot. So I've actually already run that a minute ago, so I'm going to go back up to the top here. And it tells me that my variables are correlated at 0.625, which is significant, no big deal. I want it to be significant because I get more power the more related they are. But I don't want it to be 0.999 or 1 because that will crash and burn in SPSS. So if they are the exact same column, they're not going to be, if they have the exact same information, they might be different from each other, but it may not run because the correlation is too high. Okay. So this is basically making sure it's going to run. If it is very high, try running it and see what happens. SPSS might do it. Alright, since I didn't delete anybody, I'm just going to look at my linearity plot down here at the bottom. And it actually looks pretty good. This little bump is problematic here, but the rest of the line is pretty good and close to what I would expect. Under normality here, I've got my 2 little dudes out here, so this graph should look very familiar. We've done this one before. And I would say this is okay because most of the data is between 2 and 2, and we just have a couple little people out here, and those are our univariate outliers, and our multivariate outlier. So if I deleted them, these little people should go away. Okay, at least one of them. I could look at the univariate charts. We actually already calculated the skew and kurtosis, and they are pretty good. So skew is not over 3, kurtosis is not over 3. I'm okay. All right, the next thing that happens is I want to check for homogeneity of the means, especially because I got between subjects going on. And so going across here, it's pretty evenly spread around 0. It's 3 to 3. And then going up here, it's pretty close. Most of the data is between 2 and 2, and we got like 3 little people out here that is the same, 3 little people over here. And so I would say this is probably homogeneic, but since I am running between subjects, I will get Levine's. So I could check Levine's just in case. Now, to run this test, what we're going to do is go up to Analyze, go to General Linear Model, which is the ANOVA section, ANOVA, MANOVA, and since this is got at least one repeated component, it's under repeated measures. Univariate should be labeled all between subjects, multivariate is MANOVA, and then repeated measures is appropriately labeled in the sense that anything with any repeated component goes here when you're talking about ANOVAs. Alright, so within subject factor name, I'm going to call this something I would know, so BSG, and it's got 2 levels. So you can't put in 4, even though we have 4 conditions, because our other variable is between subjects, so it's in 1 column. So hit Add and Define. There it goes. So I'm going to move over my 2 repeated components to the within subjects factors box, my group to the between subjects factors box. So this time, the thing I like about repeated measures is the windows are labeled more appropriately. So between subjects factors tells you what it is you're putting in here. When you look at the univariate version, it just calls them factors. Okay, and that should really say IVs, but, you know, can't win them all. Okay. All right, so after that, we're going to click on Posthoc. And now I've got the option again, so I'm going to move over Group and put it into Tukey. Now, and click on Tukey. Now, this window is actually not going to give me any output in SPSS because there are only 2 levels, but this is just a reminder of how you would do this if you had more than 2. You can pick several of the other options are good as well, Bonferroni, Siddock, Sheffe, the Ryan Enoch, Gabriel Welsh, and Student Newman Cools. Tukey is the one that I like because it's the best one with control that is not super conservative like Sheffe and Bonferroni when you get into running more and more tests. They each have their pros and cons. I just happen to be a Tukey fan. Okay, so I'm going to hit Continue. Okay. Under, Options, we're going to move over all 3 of these bad boys. Now, this is a window where I could get the comparisons for repeated measures, the BSG part, and I could get Bonferroni or Siddock Bonferroni. And then in this window, I actually don't need to run it either because I only have a 2x2. And so when you have a 2x2, remember you don't run any posthocs, you just look at the numbers because you've already done it essentially. Because with 2 levels, ANOVA and t-tests are the same thing. If I click on this window, it actually will give me the test no matter what. So it doesn't have that sort of safeguard of not running things it shouldn't. Additionally, it will actually give me the post-hoc for both group and BSG, so I might get 2. So you just kind of got to pick your poison. If you want to look at them, great, but don't get confused. If there's only 2 levels, that output is superfluous. Don't use it. Okay. I'm going to turn it off so I don't see it because I know I only have 2 and I don't really need it. Okay. But you definitely want descriptives, effect size, and homogeneity. Right, so descriptives will give me the estimated marginal means. Estimates of effect size will give me eta squared or partial eta squared. Homogeneity will give me Levine's. And so that's why I kept clicking it in the repeated measures videos, is so I wouldn't forget for this type of test. So I always click these 3 when I am running ANOVA. Let's hit Continue. And if you want to, you can add plots. I don't have this in the notes because this is not really the plot you want to include when you're writing this up, but it is a good plot to have to just kind of see what's going on. So I'm going to run group by BSG, hit add, and then just in case that's not the one I actually wanted, group BSG by group, and hit add. So I've got both, and I can pick which one I like better. Hit continue, and okay. So see, here's my warning about Tukey. I didn't do the Tukey because you shouldn't have. great. The problem is the compare means window under options does not give you this warning, and so it looks like output you need. But don't trust SPSS. It gives you lots of things you don't need that you didn't ask for. Okay. All right. Walking through these one at a time, this is the window that reminds you what your repeated levels are. This is the one that tells you how many people you had in each group for your between subjects factor. Here's my descriptive stats. So this is a good window to have if you can't remember what N is. Or if you're wanting to do some coincidence, you can look at the means and standard deviations here. We got boxes, which we don't want because we're not doing a multivariate test. We got the multivariate window, which we don't want because we're not doing a multivariate test. So see, extra output you didn't want. Now, sporicity would be great if we had more than 2 levels. But since we only have 2 levels of the repeated measures variable, we get nothing for sporicity because there's nothing to test. So I talked a lot about that in the last video, about why you don't get Mauchly's then, and in the first repeated measures video. So you can go back and watch those if you're confused on why you don't get it with only 2 levels. But the short version is, you can't compare correlations between time 1 and time 2, and time 2 and time 3 when there's only 2. Now, here's where the work is going down. So the first thing I've got going on is my within subjects effects box. I definitely need this one. This is the repeated measures component. Unfortunately, every ANOVA that we've talked about so far has slightly different output. So when we're running an ANOVA, we're really looking for our main effects, so we have as many of those as we do IVs. So I've got my BSG, which is a repeated main effect. I have my grouping variable. That's the instruction stuff. That's my between subjects main effect. And then, I'm going to have that interaction. So for anything that's a repeated measures component, it's going to be within the within subjects box. And so I am going to use that information to calculate the main effect ANOVA values. Okay, so it's over here under BSG. I'm going to use sporicity assumed all the way across because, well, actually they're all the same, so I can't really screw it up. But if they weren't, I would pick one and stick with it. So it's going to be degrees of freedom 1, and then you'll notice this time 156 down here. So why doesn't it look like the other repeated measures boxes? Well, the thing is that this interaction, BSG by group, the only BSG is repeated. So the error term, BSG, goes with both BSG components, here and here. And so there's not a separate error for the interaction because this is the repeated measures error, and it goes with the 2 repeated measures parts. So you don't have 4 lines here because it calculates the error based on just the repeated measures parts, and this is not another repeated part. If these 2 were repeated, you would see a separate error line. Okay, so I'm going to use 156, it's 258. Okay, p is less than 0.001, and partial eta squared is 0.62. So there's a big effect of backward strength. That's actually going to be the exact same effect I did in the last video. The interaction is also in the within subjects box, and that is going to be 156. So this is a square design. They're all going to be the same. So 156. It's 1.28. Ooh, that's not looking good. Anytime an F is close to 1, you are not doing well. And so it is not significant. So I tested this with 0.01 as my effect size and found I needed 148 people. Well, remember, power is the likelihood of finding an effect if it exists. So if the effect was there and I have 148 people, I should likely find it. So that's an 80% chance. Well, I missed it. If that effect is really there, I'm in that 20% of where I have missed the battleship, essentially. So that's beta. So there was no interaction in this version of it. If you run it as the 2x2x2, there was. And so I'm going to talk about how I would calculate the effects for interactions, because that's the point of this video, but in this case I actually wouldn't run it because it's not significant. But that's how I'd write it. The next thing you get is within subjects contrast. I'm not going to use that because that's not my point. Now, the next thing I'll have is Levene's. So I actually should have come down from sporicity straight to Levene's. But the way that SPSS stacks everything is it runs every repeated measured part, and then it runs all of the between subjects parts. And that's why they're not both at the top. That'd be nice, data screening, output, ANOVAs, Posthocs, but it doesn't work that way. And so I could look at my homogeneity, and it's going to give it to you for each level separately. And so I'm going to get homogeneity or values for level 1 and level 2. So I could actually pinpoint which level it was. Now I did that because it's treating each level as a separate DV, so to speak. And that's not the way the actual analysis runs, but that's how it will test the error variances for you. Okay. So they're both okay. BSG high sort of squeaks by at 001, but it's not 000, so it's okay. The next thing is this between subjects box, which looks, of course, nothing like the other between subjects box because there's no corrected total or intercept. There is an intercept, but there's not all these extra lines. And this is the box I would love to see for the regular between subjects. But remember, in repeated measure, the total is hidden from you. It's like magic in the background. So don't use the intercept line. But then the rest of the numbers you can get pretty easy. So 156. Right, so 156 is 3450. P-value is less than 0.001 here. And my effect size is 0.18, which is a medium effect size. Okay. So these first two are significant. So this is in the between subjects box. And that's why it's helpful to know which one's repeated and which one's between, because that's where you're going to find it in the output. And then this last one is not. Alright, so what is going on in this BSG effect? Well, I'm going to get my marginal means here. And so let's do backward strength first. Backward strength, the lower the backward strength, the lower they're rating them. Which kind of makes sense because we talked about in the last video that backward strength is an influence on their ratings of forward strength. And so if backward strength is high, it tends to it biases them even higher upwards. So I'm expecting to find them to be different because of my previous work in this field. If I had never done this before and I assumed that people were able to ignore this, they really shouldn't be different. But I already know they are. So low is rated lower than high. Okay. But low is still way overrated because these scores should be in the 20s and they're 64. Okay. Now, for group, let's think about this. So my group, this is their overall rating. So this variable to me is not super useful because this is their rating across all the different combinations of forward and backward strength. But that is how main effect works. So I can kind of see what happens with my instructions ignoring the fact that we've manipulated the types of pairs that they're seeing. So for my JAM group, their average rating is 75, which is way too high. And my debiased group, their average rating is 66. And so our instructions are doing something because people's scores are going down. So between the two groups, the instructions have had an effect, and that effect is they've brought all the scores down. And that's not too surprising because we told them, you're really bad at this. Your scores are too high because of this thing, so don't rate them so high. So everybody is sort of consciously saying, well, I want to say 8 or 80, so I want to bring that whole thing down some because they told me I'm bad at this. And then if this was wasn't a tutorial video, I would stop because my interaction is not significant. I wouldn't analyze anything else. However, this is a tutorial video, so I'm going to show you how you might analyze that interaction if it were significant. And then this is a really great picture to show you how interactions look, or don't look, rather. These are almost perfectly parallel lines, which means there's no interaction. But here is how I might analyze it. I could look at here we go. The difference between high and low backward strength for just jam, and high and low backward strength for debias. Or I could split it by BSG. So when BSG is low, what's jam versus debias? And when BSG is high, what's jam versus debias? Okay. And I'm actually going to show you both of those because they're run in different ways. In reality, only do one. So there are two options here. Oops. Oh, if I can spell today, pick one. Okay. And so what I want to do to help myself conceptualize this, if I were running the interaction, is to create myself a little box. All right. For BSG, when BSG is low, and when BSG is high. And then when I am in either the jam group or the debias group. So this variable out here is between subjects. And then this variable over here is repeated measures. So let's say I want to compare, let me pull this up for you guys, across. So let's say I want to go across these two levels and compare these two things. And so basically it would be jam for BSG low versus BSG high. Okay? And that is going to be a repeated measures test or dependent t-test because I'm comparing low to high when it's only for the jam group. Okay, and I'm in low. I, as a participant, am in both the low and the high group, so it has to be repeated. And the debias here, same idea, low versus high. And so it still has to be repeated measures because I'm in both of those conditions. Okay. All right. If I want to compare going down, what I would do is say for BSG low, I'm going to compare jam versus debias. And then for BSG high, I'm going to compare jam versus debias. Okay. And that is going to be an independent t-test because I can only be in one of those levels, either jam or debias. And so I always make one of these little charts to help myself figure out which way to go. If you go the wrong way, the test won't run properly, and hopefully you'll notice that you're getting wacky numbers. But if you're going across the repeated measures component, it's a repeat. If you're going across the between subjects component, it's a independent t, dependent t this way. Okay. Okay, all that being said, let's try the repeated part first. So I'm going to make my little t-test box. So I've got mean 1, mean 2, T and P, D, both types of D, and explain. I'm going to talk about D average and D diff. Pick your favorite one and explain what's going on. Okay. So I have got jam when BSG is low, and then I've got jam when BSG is high. So we'll do that one here in a second. And then I've got debias when BSG is low, and debias BSG is high. Okay. And that's what I want to do. Okay, that's going to be a dependent t-test. Now, the biggest problem here is that because the jam and debias variables are both included in that repeated measures column, I've got to do something special to get it out of SPSS. And I did this backwards from the notes, so I'm on page 164. So let's go to SPSS. Now, to get this, I'm going to split file. We've used split file before in the double between subjects variables, but basically my problem here is that if I just analyze low versus high, it's going to ignore the fact that I've got some in one group and some in another. Because you could do data select cases, and pick just jam, and then do data, select cases, just debias. But the faster way is to do data, split file, and organize output by groups, and tell it to do both groups separately. This just runs a little faster. Hit OK. It effectively makes it do just jam and then just debias for you at the same time. And then you'd run a dependent t. So analyze, compare means, paired samples, and then low, okay, thanks, and high. My SPSS is possessed. Let me try this again. Highlight both of them, move them over, hit OK. There we go. So what you'll notice is that it gave them to me group jam, group debias, and then it gave me 2 different dependent t's. So it gave me everything I needed. So let's calculate and add that to our little table here. So for the first one, I have a T83 is negative 12.90. Okay. And don't capitalize T, it's just a word helpfully helping me by capitalizing. The p-value is less than 0.001. For my second one, down here, I have T of 73 is negative 9.96. P is less than 0.01. Hold on to D averages and stuff. I didn't type in the means over here, but I could have. And then I'm going to scroll over here and explain what's going on. This is why I would have typed in the means. Just kind of skip that part. Sorry. So for jam, when BSG is low versus high, I've got 68 versus 82. And so my low group is lower than my high group. Not surprising, since that was the same thing as the main effect. And we're talking about 14 points. 16 points. Math. Okay, so around 16 points. And then in my second comparison, I have that my low group is the same thing as my lower than my high group. And that's about 13 points. And so that's why I'm not seeing the interaction, is that those two are almost the same difference between the two, and so there's not enough of a fan effect for it to create an interaction here. Now, if I wanted to calculate effect size, I'd go to Mote. Now, to do D averages, I do need those averages. So I'm going to move this over here, click on Measures, go down to Averages. So I'm going to pull the averages from here. So time 1, I got 68, 27, 82, 72. So about 15 points difference. And then, no, it was 14. Bad at math. And so that 14-point difference and this 13-point difference aren't large enough to create an interaction. So I know the standard deviations, so 10.84, 8.29, okay, and then N for sure, which is 84. Remember that D averages of the test statistic won't match, but we have negative 1.51. Let me do the second one here. So I got 59, 89, 72, 44. Oops. And my standard deviations, 1278, 1293. And so my effect size is 0.97. Okay, both large effects. So you can have significant differences between conditions and not have an interaction because it's the same approximate difference between them. If I wanted to do D difference, I could calculate that from the mean difference, which is found here. So negative 14.45, and then the standard deviation of the difference, which is 10.27. which is right here next to it, and definitely in, always in. So I got 1.41. And let's try this one. Scroll down a little bit. So 12.54, 10.83, and then 74. So 1.16. So sort of an interesting case because d-diff is normally larger, but it's actually a little smaller in this one, and then larger in this one. So, but if you look at them, they're both, large effect sizes, and then the difference in the reason we're not getting this interaction is because they're approximately the same pattern with the same size. That is one option. That is how you would analyze for the repeated measures components. Let's say instead I wanted to do the between subjects components. So let me relabel all this. Let's say I wanted to do for BSG low. Let's do jam versus BSG low and debias. I'm going to delete this column because there's only one type of D, unless you want to do hedges G or glosses delta. Now for BSG high, I'm going to do jam, and BSG high, I'm going to do debias. Now to do that, I'm going to turn off split file, data, split file, analyze all cases, do not create groups. But if you were doing this, you would only be doing one, so you wouldn't really have split file on. It's just an independent t-test on multiple columns. So analyze, general linear model, oops, sorry, just kidding, compare means, independent t, put grouping or grouping variable, select 1 versus 2, because that's what I've labeled them, continue. Remember, this could be anything, but whatever your groups are labeled as. And then both high and low in your test variables box. So this will let you test multiple levels at a time. And hit OK. So now I've got all my means. We'll use those in a second to calculate Cohen's d. And remember, ignore Levine's test for your t values. It's actually the exact same test as up here, if you'll notice, because that's what it did, as run on each variable. And then I just want to use t out here. So I've got t, 156, is 4.46. P is less than 0.01. And then t of 156 is 6.01, where p is less than 0.01. So to explain that, I can look here at the means, and in each case, the jam group has higher scores than the debias group, which isn't too surprising because we've told them, lower your scores, and so the debias group does. Okay. And both times it's by about 10 points. There we go. Okay, so to do D, I'm going to select measures and then independent T, and I can enter all of my numbers from here. So 68.27 versus 59.89. My two standard deviations, 84, 12.78. And then in 84 and 74. So my first effect size is 0.71. So almost large. And let's do the other two. So 82.72 versus 72.44. And then we've got 8.29, 12.93. Same numbers here, 84 and 74. And so the Cohen's d is 0.96. So a large effect size. And they're pretty close together, and that's why no interaction. So that's gone over how I would analyze the interaction as either between subjects or repeated measures, but remember you should only pick one. Last but not least, how to make a chart. So let's do this one in Chart Builder. This is one thing Chart Builder can handle. So let's go to Graphs, Chart Builder. I'm going to use this clustered bar graph because I have categorical data. I'm going to drag both of my repeated measures levels into Y, and that's the only place you can put them. Can't put them in X or cluster, so into Y. It's going to create me my index variable, which is that fake variable for repeated measures. And then I'm going to put my grouping variable into set color. Now, I could switch these and put index into set color and group into X here. And that would just depend. I would do that by the way I'm going to compare them. And so if I did jam BSG versus BSG and do BSG versus BSG, I would put it this way because it would cluster together the ones that I compared. If I compared low to low and high to high, I would flip them. And so I tend to stack bars next to each other that I have run t-tests on so that the t-tests and the bars match. Over here, let's turn on display error bars, hit apply. Let's get that x-axis something more useful, so instruction group for my particular example. Apply. Y-axis, so helpful and mean, so this is going to be my average participant rating. And I'm going to force it to go to 0 from 100 to cover the whole y-axis. Hit apply. Right, and then OK. All right, and this would be an example if I was telling it to compare my two jams together, my two biases together. Don't forget you can double click on all this stuff and change them. And so I would want to make this not be group over here. That doesn't make any sense. So we could call it BSG type. Right? And then you can actually change these as well. So low, and click once to get it, twice to get the one you want. High. And then I would change these as well. So once to get it, twice to be able to type. So jam, once, twice. Right, there we go. Now you can also solve that problem by editing the labels and value labels in the data editing window, and if you make them proper case, they'll pop out over here proper case as well. And so this would be the best kind of graph to present because it's got everything in sort of journal format already. It tells me what the error bars are, it has the error bars, and then X and Y are useful labels. So that is a mixed design and how you can analyze the interactions for mixed designs and then create a bar chart for them as well.